Number 10. Draw Lewis structures for the following polyatomic ions. Now, when we draw a polyatomic ion, we're drawing an ion, which means it's going to have a charge. So when I look at A, which is the ammonium ion, you don't have to know the name. You just need to know that it's got a charge, and the charge is +1. It's NH4 with a +1 charge. So there is 1 nitrogen and 4 hydrogens, and overall there is 1 positive charge on the whole thing. So we use our normal Lewis structure steps. I find the least electronegative atom that is not hydrogen. In this case, it is nitrogen, and I put it in the middle. I am going to write in all of my valence electrons, which you can't see here. But we see that nitrogen should only form 3 bonds because there's a lone pair of electrons, and lone pairs, right, electrons that are already paired up are not going to be involved in bonding. So they shouldn't be involved in bonding. But what's happening here is that a hydrogen +1 ion, okay, a hydrogen cation, meaning a hydrogen atom that has lost its one and only electron, is going to come wandering in, and it is actually going to latch on to that lone pair on nitrogen. Now, because that hydrogen ion is not bringing any electrons to the table, but it is bringing its 1 proton, overall, there's a +1 charge, because out of the entire structure, there's 1 more proton than there are electrons. Move on to B. So we have SO4, 1 sulfur atom and 4 oxygen atoms. Overall, there's going to be a -2 charge. So I have to spread out these 4 oxygens around the central sulfur, right? I know that sulfur is going to be the central atom because sulfur is the least electronegative element in this compound. Sulfur is less electronegative than oxygen. I know that because sulfur is beneath oxygen on the periodic table. And so I will spread the 4 oxygens out around the sulfur. Now, because sulfur only wants to form 2 bonds, just like oxygen does, it has to accommodate these 4 oxygens in a way that it does not want to. Okay? It doesn't want to. It doesn't want to have an overall charge, but to accommodate these 4 oxygens, it does have to. And so we are going to have to form 4 bonds with sulfur. 1 sulfur-oxygen bond for every oxygen. Now, we still have to have the appropriate number of valence electrons in this structure, but if we bring all of the electrons that oxygen brings to the table, all of the electrons that sulfur brings to the table, we're going to find that there are actually 2 more electrons in this than there are protons. And so that's going to give us a -2 charge overall.